Hey.
Hey, Lisa. How you doing?
Hey. Good.
Okay, so here is our Understanding Object-Oriented Programming group presentation for Lesson 7. My name is Michael Crump.
My name is Alicia Mitchell.
And first talk about the 7 steps of developing a function. One of the most important aspects of Java that we've learned so far is how to create a function, also known as a Java method. Functions are collections of statements that are grouped together to perform an operation. We've been taught to approach function creation with a thorough 7-step process that results in fewer errors, easier coding, and a better understanding of our overall program. One of the first exercises we had where we used this 7-step process in its entirety was the creation of our main menu view. We created our function as follows.
So the first step, we had to clearly define the problem. We needed to know exactly what our function was supposed to do and what our input and output values would be, and if they were any validation rules that we needed to define as well. Our function needed to result in a menu view to end users that displayed options for navigating into and out of our program. Each option on our menu would have a corresponding letter that would let the user input for their selection. So depending on their input, the corresponding output would be displayed. If the user tried to enter a selection that wasn't listed, we knew the program would return an error message to prompt the user to go ahead and just try again.
Step 2, we had to create a test matrix. The test matrix is a table that you create to show valid, invalid, and boundary inputs for all the variables of your function. For our main menu view, we knew that the variables should be each of the 7 options that we wanted to display for starting a new game, starting an existing game, getting help on playing the game, saving the game, showing the game map, viewing information about us, and exiting the program. So we placed these 7 variables on the left side of our test matrix table. In the next column, we then entered the valid inputs for each of those variables, which was the corresponding letter that was displayed to the user for each selection. And then in the next column, we entered random invalid entries for each selection. And below the valid and invalid entries, we listed what the output value should be for each. So we knew that the valid entries should return the correct corresponding selection, and that invalid entries should all return a generic error message prompting the user to try again. Because there was only one valid input for each selection, we did not have to worry about boundaries for this function.
Which was very useful. And the step 3, we needed to outline the solution for the algorithm. So an algorithm is a process or set of rules to be followed in calculations or other problem-solving operations. So we needed to develop algorithms for each of our functions to organize our thoughts and outline the problem in an easy to follow set of steps. So we used a form of pseudocode to write these algorithms, and that is basically a language that is close to actual Java language, but without all the nuisance and details of the actual code. So for the main menu, our algorithm used a generic function template for getting user input. So it prompted the user input and continued to do so while a valid value had not been entered. So when a valid value was entered, the function received the input, trimmed any of the front or trailing blanks off the value, then it went ahead and returned the desired selection.
Step 4, we then tested the algorithm. Testing the algorithm involved us pretending that we were the computer and listing out what variables would be allocated to memory for each of our test matrix cases and what the proper outputs would be for each input. This step helps us to identify any problems before we get into the actual coding, and it could be seen as like writing an outline for a research paper. We created a new table with all of the valid menu options as variables in memory locations. And then we walked through each possible input and listed what the output should be. And seeing that our test results matched our expected test matrix results, we knew that our function and design were both on the right track.
And then step 5 was to, we then translated the algorithm into code. So this is where the fun started to begin for us. We started to translate our algorithm into code, which involved taking each step and converting it into the readable Java code. And we tried to follow as much as we could closely to the algorithm. So this began by creating the function signature, which defined the inputs and outputs of the function. We prompted for the user input, and while it was valid, we captured that input as a string. We then used a string statement to compare their input against the 7 menu options we wanted to have displayed. So if the user input did not match any of the listed options or was otherwise invalid, there was a default like print line or print ln line. Yeah, that would alert the user to try again. So then we created methods for each of the switch cases that would call various menus depending upon the user's selection. So using NetBeans to develop and write the code really did help us identify the errors that did arise naturally. And as we ran the program, we could actually see what the end users could see, which was really, really helpful.
Step 6, we then run test cases to verify the code is working as specified. While we didn't use testing specifically for our main menu, the step should be utilized to verify that the function is working as specified in the test matrix. We did implement this step a couple weeks ago in lesson 5, where we wrote code and implemented test cases for one of our complex equation end user stories. The test cases are ways to verify each of the test matrix input variables within NetBeans itself. So NetBeans has a preloaded option called JUnit, which we're able to use to test the various options and confirm our expected results. If the test matrix and test case results were both equivalent, the test is considered successful. And if they're not equivalent, then the test fails, and we know we have to go back to either our algorithm or our code to correct our logic.
And then the final step, step 7, we went ahead and deployed the changes to the repository. So after we had verified all of our code and functions that, making sure that they're operating as expected with no errors in our program, we went ahead and pushed our code to both of our local and shared repositories. We first made sure to save our changes and then commit our code with the revision date and any pertinent notes for the code that we just written. So then we went ahead and pushed our code to the shared repository, which allowed us to each other's work on each other's code simultaneously, and we could either pull or push our changes back to the repository for the other team member can see or use. So it really was an excellent way to share files and to allow us to see revisions and histories. Oh, that's when we changed this, and and it really, so that way we could revert to a prior version if we found it necessary. So it was very helpful.
Okay, so here we've got an example snippet of code of mine. The code on the left was written as part of the items Java view class, which I just made this week for the individual assignment. Its function is to retrieve the user input, check to see if it's valid, and then return either the appropriate selection or an error message. So let's walk through a couple things here. The private keyword at the top means that this input can only be used by objects of the same class. The Boolean valid equals false statement indicates if the name has been retrieved or not. The while not valid statement tells the program to continue requesting input while a valid option has not been received. The two get input lines are going to get the selection from the keyboard and then trim off any of the leading or tailing blanks if there are any. The next, if get input length is less than 1, if the user inputs a selection that is less than 1 character long, we know it'll be invalid. So this section checks to see if a valid entry was input. And down at the bottom, the return get input is where the program was going to return the user selection.
And then my example code. So the code on the left that I have here was written as part of the start program view.java class that we created. It's a function to retrieve the user's input for their name and to start the program view, and which included the display banner with the user's input, which was their name. So as you can see, for our first portion of the code here, it's the public keyword, which it basically means that it could be seen and used by objects of all the classes in the code. And then the next portion that I want to show here is the string keyword, which means if the name has been retrieved. It's in a string form. And then the next portion that I would like to show is this keyword. This one I found very useful because you can use it to explicitly specify which item you're trying to reference. So it became very useful when writing code. And the next portion over here is to reference the main menu. We had to make an instance in a class in our Java code. And so we had to use the new keyword to create a new instance. And then we called it its constructor function. So when we made the new instance variable, it created a reference. And so our reference in this example right here is the main menu. And so that was able to be referenced even in the line below. And generally when you're coding, it could be referenced multiple times in other circumstances.
Then we did some control function unit tests, sorry. Creating JUnit test cases in NetBeans helps you run through your test matrix possibilities with actual code. So the below unit test was written for our water puzzle scene a couple weeks ago. And this is where users will have to determine how long it will take to fill a large tub with water. So we knew the users were going to have a 40-gallon tub of water that had to be filled 3 times at a fill rate of 2.2 gallons per minute. So stepping through the test case here, the input values here, the volume and the GPM, or the gallons per minute, we knew those were going to be the input values for the test case. Our expected result or output value was going to be 18.18. That's what we should be getting for the total fill time. The puzzle scene water instance statement is going to create an instance of the puzzle scene water class. The instance count tub fill rate statement was going to call the function so that it would run the test. And then the last line was going to compare the expected return value with the actual value returned.
Awesome. And then mine is pretty similar to Mike's, but so when we do, like Mike said, create the JUnit test cases and NetBeans, excuse me, that helps you run through the test matrix possibilities to make sure that the code is accurate. So what I did for mine is I used our teaspoon puzzle scene, which was kind of fun. And so our users have to basically determine how many teaspoons it'll take to fill a half gallon jug. So the first line here, I have 3 different inputs for the value for this test case. So there's 3 different things that we need to figure out the numbers for to input into the formula later on. And then I, excuse me, I'm sorry. Then we created an instance for the puzzle scene teaspoon class. And then this function is called to test. And then at the very end, it's supposed to compare, the end result with what we've put over here. And I did fail to mention our expected result was supposed to be 786 teaspoons, which is kind of interesting. And then our next portion that we wanted to talk about is pass by value versus reference. So passing by value means that the actual value types are copied to the corresponding parameter variable in the function. So it's very direct. That's one way to think of it. So versus a reference, and I feel like I feel like I've used references a little bit more, but this means that the value's location or memory addresses is passed in the function instead. So that's just basically the general gist. So here are a few examples. So pass by reference. So as you can see here, that's what we're mainly using in the example that I just talked about previously. And so the keyword is actually teaspoon. Now, if we generally were going to use passing by value, we would just be passing the number 3 instead of the actual keyword where the number 3 is stored with. If that makes sense? So that is a little bit about pass by value versus reference.
Okay. I'll talk a little bit about the scope and the lifespan of variables. So I got some questions. What is the scope of a variable in Java? How is the scope of a variable determined in Java? What is the lifespan of a variable in Java? And when is a variable born and when does it die in Java? So I've got another little snippet of code here. This is back from the puzzle scene water. So we've got some variables defined in this code. Variables are going to be volume and GPM. We can see it there. So the first question, what is the scope of a variable in Java? The scope defines where a variable can be referenced and then used. So these variables, volume and GPM, their scope is defined, their scope defines where they can be referenced and used. So they're defined in the puzzle scene water class, so that is where they can be referenced and used. How is the scope of a variable determined in Java? The scope of a variable is confined to the block that the variable is defined within. So these variables are they're confined to this block, the count tub fill rate block, because that's where they've been defined. So that's where these variables will live. What is the lifespan of a variable in Java? The lifespan of a variable dictates when a variable is active in memory and can be used. The lifespan of variable starts when it is first defined and allocated in memory. So these variables come to life once they're defined here in this block, the count tub fill rate block. That's when they first um, come into existence, I guess. And when is a variable born and when does it die? A variable's life begins when a variable is defined and ends when execution leaves the block that the variable is defined within. So once we reach the end of this block with the tub fill rate, then these variables sadly pass away. It doesn't mean they can't be used later in the code. It just means that for this block, their function is done. And then they're removed from memory. That's it. That's our presentation.
Thank you for joining us.
Thank you.